Nanotechnology is flourishing. Professor Naomi Halas at Rice University in Texas is making massive medical advances, but on a tiny scale.
It's an interesting question to think about how something that small could actually be that useful. And the reason that objects and structures, devices on that length scale are in fact useful is because of that size. That's a size where one is just a little bit bigger than the fundamental nature building blocks, atoms and molecules. My major interest is the interaction of nanostructures and light. So it's a field within nanotechnology called nanophotonics. It's a rapidly growing field because it has within it many practical applications for nanotechnology that range across a whole variety of different disciplines.
Nobody's ever been able to get any information about molecules that insert into membranes.
One can build nanotools that do new things that can, for example, in our own work, that can selectively target cancer cells and destroy them at the cellular level. Nanoshells are essentially nanolenses that capture and focus light around themselves and can be effectively delivered to a specific organ or tumor through the bloodstream. Once in place, infrared light can be shined through the skin and into the tumor. The nanoshells absorb the light and convert the light to heat. The heat destroys the tumor cells. Compared to current cancer treatments, this will be very safe and non-invasive. I'm also interested in seeing how this type of approach might be useful in other diseases as well. It's very interesting to see how medicine and medical researchers respond when exposed to what might be a disruptive new technology. In fact, I've been quite surprised at really how positive people have responded. And I think this is something that people really need to remember, that most people who are involved in medicine and at any level really came into medicine because they wanted to alleviate human suffering. So in general, even when exposed to a new technology, you find people who get very excited about it because they realize this is something that will actually help them achieve their goal. In terms of the overall impact of this approach in medicine, I have very high hopes. One of the most exciting elements of nanotechnology in general, and in particular nanohealth interests, is that there is a possibility of greatly reducing the current costs for diagnostic medicine. We think of, for example, drug development as being incredibly expensive. What nanotechnology offers in many ways are simple ways and low-cost ways of manufacturing different types of both diagnostics and therapeutics. And ultimately, one could imagine that nanotechnology might really make the difference in terms of the availability of healthcare for both developed and developing countries. And the reason that I say that nanotechnology is going to be part of the future is because it already is.
From the smallest of scales to the biggest, Gerhard Knies and his organization are endeavoring to put the deserts of the world into service. His aim? To solve climate change issues, provide energy for the planet, and to encourage a new kind of cooperation between nations.
Solar energy coming to the deserts is the largest and at the same time least tapped resource of energy we have on Earth. In 5.7 hours, the deserts of the Earth receive as much energy as the whole world is using within 1 year. I am the coordinator of TREC, the Trans-Mediterranean Renewable Energy Cooperation. This is a network of about 50 scientists, engineers, politicians, and also some business people. And we have the intention to put the deserts into service for energy, water, and climate security. Solar energy is really becoming competitive with the fossil fuels, but harvesting the solar energy takes some more efforts than just pumping oil from the ground. So solar energy is slightly more costly. However, this does not include the follow-up costs of using the oil, by climate change, by pollution, and all of these devastating effects. The Trans-Mediterranean Renewable Energy Cooperation is not trying to solve all problems with solar energy. We are looking at all the resources that we have: solar, wind, hydropower, geothermal, biomass, and so on. And all these technologies will make their contribution and give us more security in the supply. The necessity of a changeover from fossil fuels to renewable energies is becoming urgent because of the climate change that we are inducing. This is the responsibility of governments to take care of the future. Governments have to set new targets for the energy system, and then governments have to develop policies for this, and then they have to enforce these policies. Once governments are doing this, business will just follow. We have to change our political style. If the countries from the Sun Belt and from the Technology Belt, from Europe, Middle East and North Africa, if they would understand themselves as a community for energy, water and climate security, they could resolve all these problems. So we have to begin to develop our understanding of this region as a region with a big potential if it begins to cooperate. The fossil fuel system and also our economy right now is just organizing our collective suicide, because we cannot survive in this way. I find it challenging and also rewarding to work out ways into the future which are not harmful to ourselves. And that's why I'm doing this, and that's why I'm enjoying it.
And where will this power be going? Much of it into the world's ever-expanding cities. In part 3, we take a look at how the design of those cities is going to be crucial to our future.